Today, we're very excited to be introducing the Lean CLI. The Lean CLI was a project to make Lean easier to debug, so you could get some beautiful autocomplete and use the Lean engine on your computer with very minimal setup. So this was the work of Jasper for the last little bit, and we're very excited to finally be publishing it to a sort of public beta to the community. And yeah, thank you very much. And without further ado, Jasper.
I'll just leave this on. Hello, I'm Jasper. As Jared said, over the past 2 months, I've been working on the new CLI. Basically, the Lean CLI is a cross-platform command line interface, which has 2 primary goals. First of all, it makes it easier to run Lean locally. So it makes it extremely easy to run backtests, to debug backtests, to run optimizations, and to start local live trading. And on top of that, it also provides the same functionality for cloud algorithms. So the CLI can download your projects from QuantConnect to your local drive. It can upload changes, local changes. It can start backtests in the cloud, start optimizations in the cloud, and start live trading in the cloud. And the beauty of the CLI is that you can basically mix and match between between the cloud and your local environment. So you can, for example, download a cloud project from QuantConnect to your local environment, then do some debugging locally, and finally push your changes back to QuantConnect to run your backtest and your live trading all on the QuantConnect platform. So today I will be showing you how you can install the CLI, how you can use it, and yeah, just the basic usage of the CLI. Let me see, 1 second, I can share my screen, I hope. Jared, can you go, your host, right?
Yeah.
Can you see a security button? And allow screen sharing. Oh, no, I'm host, that works too. Share screen. Do you see something or?
Yeah. Okay.
Right. So the CLI basically has 2 prerequisites. You need Python installed and you need Docker installed. For the sake of this demonstration, I'm not going to do that on stream because you need to restart your computer in the process, which I can't do, but I've already got both installed. So as soon as you've got both installed, you can simply run pip install Lean and hit enter, and the CLI will install. The latest version is 0.1.24, and after this meetup, it will be 0.2.0. And from there on, we will keep adding more features. After that, you need to create a new directory. So the CLI works from the principle that you have one directory in which you have all your Lean projects. If you are used to Skylight, which is QuantConnect's current desktop application, that would be the QuantConnect directory in your home directory. But I will just create a new one in my projects folder. So let's go Lean CLI demo, open it, and open a terminal in it. And then the first step will always be to run Lean in it. So what this does is it downloads the latest sample data from the Lean repository and creates a simple configuration file, which is used when the Lean engine runs locally. So I will give this a few seconds to run, and hopefully it doesn't take too long. It's about 200 megabytes of data that needs to be downloaded. By the way, if you have any questions during this presentation, just ask. But hopefully this will be smooth. All right. So after downloading the data, it will ask you what your preferred language is. This is the default language when you create new projects locally. So the CLI supports both Python and C#, but I'm more of a Python user, so that will be the default. And then basically it tells you some basic information of how to use the CLI. As I just said, it creates a Lean configuration file and it downloads some sample data. So, well, this is the created folder. And if we open this in VS Code, we can quickly inspect the lean.json file, which contains the configuration that is used when running the Lean engine locally. And the data directory contains the local market data that is, again, used when running the Lean engine locally. And in a few minutes, I will show you how you can download data from QuantConnect to this data directory using the CLI. So in this case, the first thing I will do is I will download my projects from the cloud to my local environment. So on this account, I've got 3 simple projects, and I want to download those to my local directory. So to do so, I can simply log into the CLI. And after that, it's already displayed here, I can run the Lean Cloud Pool command to download all my projects to my local drive. So first I need to log in, which requires me to provide my user ID and my API token. I can find both of these on the account page on QuantConnect. All the way on the bottom, there's a link to request your token and your user ID. Simply click on it and go to your email and wait a few seconds for the email to arrive. And then you get your user ID and your token. If you provide those credentials to the CLI can then make authenticated API requests in your name, and basically all the cloud features will be enabled. So once that's done, I can simply run Lean Cloud Pool. And this will download all the projects from the cloud to my local environment. And besides that, I will also create the necessary editor configuration so that when I open one of these projects in my editor, I will automatically have auto-completion fully set up without having to do anything. So in this case, it created the Forex crossover, SPY buy and hold, and SPY crossover projects. And for example, in the Forex crossover project, which is a Python project, it has already created a PyCharm configuration and the VS Code configuration. So I will open this in VS Code. And well, this is a basic algorithm that I wrote in advance. Someone want to ask a question? It's a very simple crossover algorithm on the Australian dollar US dollar pair. It takes a fast EMA and a slow EMA, and if the fast value is above the slow value, it buys Australian dollars, and otherwise it sells them. So no magic here. It's just to demonstrate how it works. As I just said, you get automatic auto-completion. So for example, if you want to create an EMA, you can simply type the function and you get a full description with all the expected parameters and the return type. And this works on all the types in QuantConnect, as well as in all the types in the system namespace. So if you reference C# types in your Python code, you also get auto-completion on that. So now let's say I want to change this a little bit. So let's say instead of a slow period of 10, I'm going to set it to 5. And now I want to test this change. So you've got 2 options with the CLI. You can either run your backtests in the cloud, or you can run them locally. I will first show you how you can run a backtest in the cloud. So basically, you run Lean Cloud Backtest, and you specify the project name. In this case, it's Forex crossover. And you specify that you want to push your local changes to the cloud before running the backtest, and that you want to open the results in the browser once the backtest is finished. So this will first push the local changes, which in this case is the main.py file, and it will compile the project in the cloud and run the backtest and keep you up to date about its progress. Just take a few seconds. And the backtest will automatically open in the browser once it's finished. And then you get the beautiful charting on quantconnect.com with the results. Well, this is not a very good algorithm, but still 11% is okay. So you get the full results. Also in the terminal, you get a small little summary of the statistics. So if you don't want to open it in the browser, you can still see whether it's somewhat successful. So that's for cloud-based backtesting. I will also show you how you can run a backtest locally. So before you can run a backtest locally, you need to make sure that you have the required market data for your algorithm. So in this case, I'm using hourly Australian dollar, US dollar data from Awanda, which requires me to have this data available on my local drive. So in the data directory that was generated by Lean init, there needs to be in the Forex folder, Awanda hour, there needs to be an Australian dollar, US dollar data file containing the data points for that pair. So the easiest way to get this is to download it from the QuantConnect data library. The QuantConnect data library is basically the data library that's used when you run your backtests on QuantConnect. And we offer you the CFD and the Forex data for free. So you can download all the data that we have on that to your local environment. But first you need to add it to your local account, to your QuantConnect account. So you can simply browse to the data that you want in your local environment, open the data file that you want, wait a bit for it to load. I know. Okay, that works. And then you can add it to your account. So first you need to add it to your cart, and then you need to accept to the terms and conditions of QuantConnect, basically, which basically say that you cannot redistribute the data yourself. So that's done. And now I can simply, in the terminal, I can say Lean data download. I need to specify the asset type. So in this case, it's Forex. I'm downloading from the Awanda market. The ticker is AUD/USD. And the resolution is hourly. So this downloads the data file that I just added to my QuantConnect account and stores it in the data directory. So in the zip file is all the data for this pair from 2002 all the way until yesterday, I believe, or 2 days ago, actually. So now I can simply run the backtest locally using the Lean backtest command. I specify the project name again, which is Forex crossover. And this will run the Lean engine in a Docker container and add the local data directory as well as the Forex crossover algorithm to that same Docker container, and then run it using Lean. And as we can see, we made a total of 308 trades, and the return is the same as in the cloud. So we have the exact same data as the data that we have in the cloud. Just a little bit. Let's see, what now? Any questions so far, by the way? No, okay, that's great. So I will now show you how you can debug your backtests locally. So I've just shown you how you can run it, but the advantage of the CLI is also that you can easily use your editor's built-in debugger to step through your algorithm line by line. It's actually pretty simple. You simply set a breakpoint wherever you want. And then depending on your editor, the instructions change a little bit. So for VS Code, I can say Lean backtest Forex crossover debug PTVSD. In the case of VS Code, you need to use the PTVSD debugger if you want to debug Python. If you are not using VS Code and Python, however, you can go to the documentation of the CLI. And underneath tutorials, backtesting, debugging local backtests, there are instructions for all major editors. So the CLI supports PyCharm, VS Code, Visual Studio, and Rider. Yeah, basically go to this page if you want to debug. There are tutorials for each and every editor that we support. So I'm using VS Code. And the steps are basically to first start the Lean engine in debug mode, and then connect to the debugger in the Lean engine using VS Code. So Lean tells me that it's waiting for the debugger to attach, and at that moment I can simply go to run and debug in VS Code, select the debug with Lean CLI configuration that's automatically created when you create a new Lean project, when you create a new project with the CLI. And once I run that, it will automatically hit the breakpoint the moment it reaches it. And then you can inspect values, in this case of fast value and slow value, and see that fast value is indeed greater than slow value. So the algorithm is working as expected. Oh, stop debugging. Now. And I can stop it. Hopefully. So that's debugging with CLI, and this works similarly as well with C# in Visual Studio and all the other editors that we support. The only little bit is that if you use PyCharm, you need to use the professional edition. So be careful about that. Besides running backtests, you can also start a research environment locally with the CLI. So for people who are used to QuantConnect, you can open research notebooks on QuantConnect.com. Similarly, the CLI can also start a similar research environment locally. So what I can do is say Lean Research Forex crossover, which will automatically open a browser, will automatically start a Jupyter Lab instance and open the browser, and then I can just open the research notebook that I want to use, and in there you can work on your Python notebooks. So you can run Python code interactively and do things like plotting or working with your local data. I made a mistake. I'm not going to fix this now. Anyhow, you can basically do everything you can do in a normal Python notebook, and you have access to all the same libraries that your algorithm has access to, which are the same libraries which are available on QuantConnect.com, because they are both using the same Docker image. I see there are chat messages. Over. Okay, so we just speak this for YouTube. I run backtests for my options algorithms based on a dynamically filtered universe. Working with minute resolution over a decade can take a really long time when backtesting in the cloud. With a powerful local machine, is there a way I can run backtests faster without having to download the universe of options data? No, in general, not. If you run your backtest locally, you need all the data locally. So you can't mix and match with the cloud. There is a data provider in Lean which automatically downloads files from the QuantConnect data library when your algorithm needs it, but you still need to download it one way or the other. And by the way, at the moment, you can't download options data yet. We provide Forex and CFD data for free. And in the near future, you will also be able to download data of other asset types through the data library. But I will leave that bit up to Jared if he wants to talk about it after my demonstration. So the next step will be to optimize the algorithm. I will quit out of this environment. So you can use the CLI to run the optimizer in Lean. So using that, you can, for example, in this case, find the best periods for the fast EMA and the slow EMA, which is actually quite simple. You simply need to get rid of these constants first. So these constants can't be optimized the way they are at the moment. You first need to convert them to parameters of the algorithm. And after that, you can optimize these parameters. So to do that, you can simply go to the config.json file, which is generated for each and every project, specify the parameters that you want your project to have. So in this case, I want a fast period, which I will default to 5, and a slow period, which I will default to 50. And then in my algorithm, I have to retrieve these parameters. So I can say fast period is the int representation of the get parameter result of fast period. And similarly, I want the slow period to be the result of the slow period. And I replace it to values. And then I can use the CLI to optimize these two parameters. So I can simply say lean optimize 4x crossover. And then an interactive wizard will start to configure the optimizer. So you can choose between grid search and Euler search. The first one basically goes through all combinations, while the second one starts with a big step size in parameter values, and then gradually becomes smaller as it approaches its target. So for this example, I will use the grid search. Then you need to select the optimization target. So I will go for a maximal annual return. And you need to configure, of course, the parameters. So you need to specify the minimum value, the maximum value, and the step size. To keep it somewhat fast, I will limit the amount of possible options. So the fast period will be between 5 and 10. The slow period will be between 25 and 50 with a step size of 25. And then you can add some constraints. So basically a constraint on an optimization says that if you have a constraint of drawdown less than 25%, then all parameter combinations which result in a drawdown greater than 25% are dropped from the result. In this case, I won't add any constraints, and the optimizer will automatically start running. It should be about, I think, 12 combinations, and I have 16 cores here, so this should be reasonably fast. In the meantime, someone asks, does Lean CLI automatically update the containers when I run the backtest and research locally? At the moment, no. It only downloads them when it needs them. However, you can specify the --update flag to a command. So, for example, name --update, and if you run it like this, it will first pull the latest version and then run the backtest. And the CLI does automatically give you warnings when you run an old container for too long. So every 2 weeks, the CLI will automatically do a version check to see if you are still running the latest version, and if not, we'll give you a warning about it. So this finished relatively quickly. In the last line of the debug, you can always see the result. So you get the optimization is ended with a result, and in this case, the slow period of 25 and the fast period of 9 resulted in a compounding annual return of 12.32%, which happens to be the best in this case. So we can use this in our algorithm. So we could set this to 25 and this to 9, and if we now run a backtest again, it uses these periods. Getting to the end here. So the last thing I want to show you is how you can start live trading using the CLI. I will show you how you can do it with the cloud, because I don't want to show you my brokerage credentials right now. So to do that, similarly to running backtests, you can run Lean Cloud Live, then specify the project name again. Nope. Specify that you want to push your local changes to the cloud, and that you want to open the results once they are ready. So this will first push the updates to the cloud. So it updated the main.py file, the research notebook, the parameters, and the parameters. And then it started the wizard to let me configure the deployment. In this case, I will deploy to paper trading, to the paper trading brokerage. Normally, the second step is to configure your credentials for your brokerage, but the paper trading brokerage doesn't have any credentials. The second step is to configure notifications. So QuantConnect can send you notifications when your algorithm generates an order or an insight. So for example, I can set both to yes, and then I can configure the exact notifications that need to be sent. Let's say I want to send SMS notifications to a phone number. So let's say +316. I'm not going to type my real number in here. And let's leave it at that. Then you can also configure automatic algorithm restarting, which basically automatically restarts your algorithm if a runtime error occurs. So for example, if your brokerage disconnects due to an API error, we can automatically restart your algorithm for you. So we usually recommend setting this to yes. And then you will have to confirm whether your input is correct. In this case, everything is, so I can simply say yes, hit enter, and the deployment will start. And if everything's okay, the results will open. This will take a little while to start, so I'm not going to wait actually, because the algorithm trades on hourly data. So before the first order is placed, it will be 20 minutes. There is a question, what are the steps to run live trading locally? That's completely documented. I can find it right here. So in the tutorial section, live trading, local live trading, sorry. There is a guide on how to do this, but basically you have to configure your in the lean.json file your brokerage credentials for the brokerage that you want to use. And you have to configure the environment in which Lean has to run. So you already get a bunch of brokerage environments set up. So for example, for Tradier, you need this configuration set up. And then somewhere up here, you need your Tradier credentials. I don't know exactly where it is. Right here, you need to provide your brokerage credentials. And then in the terminal, you can run Lean live. In this case, it would be Forex crossover. And then live Tradier, which is the environment on the bottom of the lean.json file containing the environment. And I think this has started. Oh, Jared in here. How can we contribute or report bugs and request features in the CLI? Well, it's all open source. So in case you want to help out, this is the repository. You can leave issues in here if you have any more questions after this meetup. And I will be answering them as soon as I can. And yeah, so I think that's it. Can you please demo local live? Let me see if I have brokerage credentials that I can show on stream. Without the credentials. Yeah, I can show it.
Maybe just it could fail at the login stage, just with
yeah, that's doable. I can provide fake account names. Let's say my IB account is what's realistic trader 777. That's a valid name. My username will be 14567, and my password is going to be 102. I'm an individual with a paper account, and I don't want to do delayed data. And I already have my it's called live interactive environment set up, which will connect to the interactive brokerage. So, well, this is not a oh, never mind. Interactive brokers does do Forex, so this should work. And then you can do live interactive. This will fail at the login stage, but So this starts the IB gateway in the Docker container, and then basically automatically logs you in to that GUI. We've got that all automated. I don't know if Stefano is in this call, but thank you very much. So this failed pretty badly. I don't know why. I'm going to assume it's a login error, but it doesn't seem to. I think it's a login error. Well, it's not. I'll fix this after this meetup. No one saw this. There have been some updates to the IB automator lately, so that may have triggered something weird. But in general, you can just start live trading this way, and it works with every brokerage that Lean supports. Yeah, that's basically how it goes. There is a question in the chat. How many assets can the CLI download in a single API call? For example, to backtest a basket of 10 assets, do I need to make 10 CLI API calls? In a single API call, you can download one asset. So depending on the resolution of the data, the amount of requests changes. So hourly and daily data is saved in one data file. So downloading the hourly or daily data for an asset takes one API call, but minute, second, and tick resolution is stored in per day data files. So if you want to download 300 days of minute resolution for a ticker, that will take 300 API calls at the moment. Multiply that by 10 for 10 assets. It just depends on the resolution and the resolution basically, and the duration of data that you want to download. How do I generate a backtest report? That's a good one. I completely forgot about that. So locally, if you run a backtest, if you run a backtest locally, the results are stored in the backtest directory. Oh, I completely forgot to save it. Oh. If you run a backtest locally, it gets saved to the backtest directory, timestamped to your to the timestamp. So everything is saved in a JSON file. So for example, the main.json file contains most results containing all your orders and the closed trades. And on the bottom, you've got the complete statistics. So you can, of course, build your own visualizer around this data, but an easier way is to just generate a backtest report, which can be done using the lean report command, to which you have to specify the backtest data source file, which is this main.json file, which is currently stored in Forex crossover /backtests /2021 03 26 to 27 22. It's the main.json file. So this runs the report creator in Lean, which will automatically create a pretty report of the backtest containing a bunch of charts to explain what the backtest has done. And it generates it to the report.html file in the current directory. And if I open that in Chrome, you will see the complete results of the backtests in a more visual manner. So you get the key statistics, the monthly returns, and then a bunch of charts explaining what the backtest has done. All of this, again, is documented on the documentation, including complete explanations of each chart. Alex asks, we can put it in a batch script, right, to download data. Yeah, sure. You can create a batch script which contains a bunch of Lean CLI calls, if you want. You can call the Lean CLI like any other CLI, so you can use it in batch scripts, and yeah, that works. How do you use the random data generator? So you can also generate random data using the CLI. For example, if you don't have data, if you want to backtest your algorithm against a lot of data, but you don't have the data locally. You can generate realistic looking data using the CLI, using the Lean data generate commands. And I must admit, I kind of forgot how to use it. So, I see. So basically, Lean data generate. There are two required arguments. First of all, you need to specify a start date. So let's say 2020 or 101. The end date defaults to today, so that's fine. Then you need to specify a symbol count, which I will set to 3 in this case to keep it somewhat fast. And then you can specify a bunch of options to generate the data that you want. So you can generate data for each supported security type and resolution with custom densities. And when you run this, it automatically generates minute equity data for 3 randomly generated symbols. And this is going to take a while. But anyway, this generates random data, which you can then use in your algorithm to test against a bunch of data if you have a need for it. How would I use alternative data with the CLI? Good question. You can still, so in QuantConnect, you can import custom data using a custom data reader. That also works locally, so you could still use that. You won't have automatic access to the data sources that are in QuantConnect. So for example, on QuantConnect, we have a bunch of free alternative data, which you don't have access to locally, of course. But if you have your own Tingo API key, you could still use that. Quandl also has API tokens, which you can, Quandl can also be used locally if you have an API token, I believe. And yeah, that's basically the way to go, I think. Where can I find documentation for this? So it's all on this website. I'll leave this page off. This is on the new documentation website, which will hopefully soon become the default. But at the moment, we have documentation in various formats. First of all, we have user guides containing some of the how does the CLI work and why does it work this way. And we got some tutorials, which are basically tutorials and API reference for all commands. So if you are in doubt, just go to the documentation. Oh, can't even post it. Oh, I can.
Cool. If there are any last questions, please feel free to shoot them through. Well, thank you very much, Jasper. I'm really excited by this. It's amazing to see Lean so easily used. So yeah, this is really, really awesome, Jasper. And just to add on to what Jasper was saying, so the QuantConnect data repository, we're working now with the vendors who have sold us the data, and we're updating our licenses so that we're allowed to redistribute parts of it. So, for example, US equities, US futures, options, future options, and futures, but not index options, we'll be able to provide for download. So you'll be able to just put in the API data downloader and run a backtest, and whether or not you even have the data on your computer, it will find the data in the cloud and then add it to your account automatically and make it available for download. So we really want it so that the data downloading and running Lean locally is incredibly seamless and painless. So we're pretty excited by the CLI and all the new potential that it can bring. So yeah, great work. Last couple of questions for you, Jasper.
Yeah. Do we need VS Code as well to use the CLI? No, you don't need VS Code in particular. You do need an editor to work on your algorithms, but which editor that is doesn't really matter. We officially support VS Code, PyCharm, Visual Studio, and Rider. So if you use any one of these four, it will be the easiest. But it doesn't really matter which one you use.
Fantastic.
Linux and Windows support, yes, we support Windows, Linux, and macOS. If you do a C# on Linux or macOS, though, you do need Mono installed, because at the moment QuantConnect still uses .NET Framework, but in the near future that will change to .NET 5, so that's gone as well. Is there something I need to do in the editor to connect it to the CLI? No, in general, not. Auto-completion should work with other editors as well. We can just make it seamless for the four that we support. And well, debugging will be a little hard if your editor is not one of the supported ones, because your backtest runs in a Docker container. So you need to attach to the debugger in the Docker container, which can be a bit tricky depending on the editor that you use. But no, you don't need to do anything to connect it. So you don't need to click a button or something. Other than debugging, every editor will work. I think that's it. If someone has any other questions, just you can ask them on Slack. I'm on there too, and you can open an issue in the GitHub repository in case it's Lean CLI specific.
Awesome. Thank you very much, everyone, and thank you so much, Jasper, for presenting and all your hard work. Really. All right, everyone. Take care. Have a good night.